Big aircraft assembly is all about integration and order, bringing thousands of precision-made parts and subassemblies together into a single airworthy structure with predictability and repeatability. The philosophy emphasizes breaking the airplane into manageable chunks, wing sets, fuselage barrels, tail sections, building them in parallel, then methodically joining them under strict quality controls so the full aircraft functions as one flying system. Precise assembly sequencing ensures systems, loads, and structures align for durability and safety. The wing assembly starts with major internal structures, spars, ribs, and stringers that define the wing's strength and airfoil shape, then add skins, control surfaces, and fuel system components. Because wings carry lift and fuel, their assembly is highly controlled and often performed in dedicated fixtures that ensure exact shape and alignment before integration with the fuselage. This step also includes installing flaps, slats, and actuators that allow the wing to perform throughout flight. Fuselage assembly brings together long cylindrical sections made from metal or composite subassemblies, which are aligned and joined into the main body of the aircraft. These sections are often built separately in smaller jigs and then craned or moved on fixtures into a final assembly station, where careful measurement and fastening bring them into a straight, load path-ready structure capable of pressurization and flight loads. The empennage, or tail assembly, provides stability and control and consists of the horizontal and vertical stabilizers, elevators, and rudder. These parts are usually smaller than wings or fuselage, but must be built and joined with the same precision. Alignment tolerances directly affect control authority and balance. In practice, the empennage is assembled, aligned, and tested before it is mated to the rear fuselage section. Major joint operations are the high-stakes moments in assembly where large structures are mated together, like wings to fuselage, fuselage sections to each other, and empennage to fuselage. These operations require massive jigs, cranes, or air cushion systems, and everything must align first time because even tiny misfits can introduce stress, vibration, or fatigue problems. The aircraft is usually moved from station to station as joins are completed and systems get installed. Once the big structural pieces are joined, systems installation begins. Wiring harnesses, hydraulic lines, avionics, fuel lines, environmental control systems, and landing gear are integrated. These systems are installed along pre-planned routes, while technicians follow quality standards so that all items work seamlessly when final tests begin. Integration sequencing is important so that later systems don't interfere with earlier installs. Alignment and tolerances are essential because even small misalignments can cause aerodynamic imbalance, vibration, or structural stress during flight. Assembly teams constantly measure and adjust components so that loads flow as designed and connecting points sit precisely where engineers specified. Modern tools like laser trackers and digital metrology help ensure that critical dimensions are within tight tolerances, ultimately affecting the aircraft's performance and safety.